not necessarily a full house, but I think we've got a quorum. So let's get started. My name is Professor Werwath. We're here for a panel session on clean tech careers, put on by the Northwestern Master of Engineering Management program. It's no coincidence that all of the folks on this panel tonight are associated with MEM. We've got 4 alum of the program from 2016 and 2017. We also have our executive in residence here, Mark Johnson. I'm going to have them each introduce themselves and give us their story as to how they found themselves in the clean tech, what their backgrounds were, how they got into clean tech, and what they're doing now. And we'll just go from one to the other. We'll go in the same sequence that we published. So first up would be Aditya. If you want to go first, Aditya Divekar, MEM 2017. You're currently a technical program manager at Nikola Corporation. So Aditya, why don't you take it from here?
Yeah, thank you, Professor Werwath. I'm not just checking real quick if you can hear me.
We can hear you.
Awesome. Hi everyone. I'm excited. I'm ecstatic to be here on this panel today. Thank you for the initiative, Professor Werwath and Sachin. I'm an MEM 2017 graduate. Right after graduating, I started working at a startup based in the Valley, Silicon Valley, for a couple of years. Basically, right after MEM, I transitioned from, so before MEM, I was into the technical role. So right after MEM, I basically transitioned into a technical program management kind of a role. And that's where MEM helped me a lot. Basically, the key requirements for the role, like communication skills, problem solving, negotiating, all the coursework, all the peer-to-peer interaction during MEM basically helped me grow my skills, and then eventually get into clean tech industry as a program manager. I have about 8 years of experience in the automotive industry in general. Initially started off my career as a calibration engineer, which was in the conventional internal combustion engines, and then slowly moved into clean tech.
Okay, thank you, Aditya. Nice job. I think I have Vignesh next. Vignesh Ramasamy was an MEM 2016 alum, or graduate, I should say. He's a techno-economic analyst at the NREL, which is the National Renewable Energy Lab for the U.S. Department of Energy in Boulder, Colorado. Vignesh.
Hey, thanks, Professor. This is great. I mean, as an alumni and from the shoes of current students, I could say that this is a great initiative for the MEM students to get in touch with employees in a particular field. But anyways, I'll just give a little bit background about how I landed a career in clean tech. So I was a business analyst come entrepreneur when I arrived at Northwestern University, and I never had any experience in the clean tech industry. And I was an electronics engineer by bachelor's. So, I was more passionate about analytics work and, entrepreneurship, and also wanted to learn certain managerial skills. And that's one main reason for me to pick MEM at Northwestern, as they offered me to, kind of tailor my coursework that checked every skill I wanted to explore and master. And during the summer break of first year, a group of MEM students, and Sachin was also part of that group, were fortunate enough to be offered an opportunity to conduct, techno-economic analysis by Professor Werwath and Mr. Johnson. They oversaw the analysis work that we did, and it was kind of a partnership between two companies, I guess, Schneider Electric and Vision Energy Systems. And during that short stint as a group, we got the opportunity to learn about different energy analysis and optimization tools used in sizing PV and energy storage projects. And not only that, we also validated a techno-economic financial model. And that kind of helped us to use all the skills we have gained from the technical coursework and then the business coursework at MEM. So this project, that project kind of kindled my interest towards clean energy. And the next year, I did all my academic projects, linking them with the clean energy organization, which helped me to build experience in the sector and also, converse with the employers in that sector with what I was able to do through the academic projects. So at that point, I kind of figured, what type of job roles I was comfortable with working in the industry, and got in touch with people having similar background in the industry. And, eventually I landed interviews and gave my perfect pitch to get my first job offer. So it was intense, but also, a bit luck worked on my way, to be honest.
Well, you've had an amazing career. I mean, we're all very proud of you. So I want to thank you for being here tonight. I have Ajinkya next. Ajinkya Shirude is a 2016 graduate of MEM. Ajinkya is working currently at Tesla Incorporated as a program manager. So want to take it away, Ajinkya?
Yeah. Hi, everyone. Hi, Professor Weber. Thank you for organizing this. I think, yeah, this is really good. And the initiative, I think, is good. So I'll give a quick, background. So I did my engineering at Purdue, and then I got into the heavy automotive business. So basically trucks, buses at Navistar. So I started as an engineer there, solid mechanical engineering field. So body engineering is what I started with. And then I got my MEM degree part-time while working in the Chicago area. And that's where I think the program management field and the engineering management field kind of really started to seem interesting. Navistar was, when I was there, it was in the middle of the, I think some of you might know, the engine crisis. So between SCR and EGR, like selective catalytic reduction, and basically exhaust gases recirculation. So it was basically a big engine dilemma with emissions. And at that time, Tesla was a small name. The Roadster was out. I think there were talks about like Model S coming out. And I realized that there's a whole new industry that's coming up and basically growing in the background, which I should start looking into. So while getting my master's at Northwestern, I started talking to different professors. I think that's something that really helped me in figuring out, I like finance. I like the more management side of things. And I went and worked for a supplier after that, a battery manufacturing supplier. I was in Detroit for 4 years after I got my MEM. Worked with German OEMs such as VW, McLaren. McLaren is UK, but yeah, VW, Porsche, Audi, all the German OEMs really understood the lithium-ion and the battery industry. And that was basically how I got into Cleantech. So, and then after that, I moved to Tesla as an engineering program manager in battery. So I've been here since about 9 months now. So not too long at Tesla, but just enough to get my feet wet and understand what the company is doing, what the next products are. And yeah, really excited to be here. So.
All right. Thank you, Ajinkya. It was great to have you. For some reason, Sachin, I think I lost your slide. Maybe Rivian took it from us in the middle of the night here. But Sachin is an MEM 2016 alum, design release engineer for the powertrain cables division at Rivian Automotive. If people don't know, Rivian is a SUV truck startup, fully electric, based in Normal, Illinois, unless you want to say Palo Alto or UK, but it seems like they're everywhere. So Sachin,
like
take
California
it away.
too. Yeah,
California too.
Yeah. Thank you for having us here, Professor. Vignesh pretty much took my thunder away when he spoke about how we got into the Cleantech. Not to repeat what Vignesh said, but I found myself in contact with Professor Fairwath and Mark, and the 2016 project with Snyder and Wyzen Energy basically opened my eyes to the field of clean tech. Apart from engineering, one of the things that really struck me was, how much of an impact that you could do to the environment, and along with that, the monetary benefits that you would realize by in engaging clean tech technologies, right? So at that point on, I thought, how would I transition to this field? Because my transition to this field was not premeditated. I had no clue that a tech called clean tech industry existed, and had no interest of transitioning until that internship. It's only at that point I realized, there's something here that's valuable, some that could be done, and there's also something that that gives you an opportunity to do a greater impact to the planet. So after the internship, I started reflecting, and I asked myself, is this a place I want to be, and how best I could utilize my skills to contribute in this field. So at that point, automotive has been my primary focus, and that's been one of the core reasons why I got into mechanical engineering. And I try to see how I could piggyback off my experience here and at my previous experience. And then I realized, getting back into engineering that's primarily focused on clean tech was the way to go. And then subsequently, I changed my job hunting strategies to focus purely on clean tech startups. One of the reasons I focused on clean tech startups is basically because the growth that a startup would give as opposed to a big company. Because at a startup, you pretty much wear multiple hats. Each day is different from the other, and you holistically develop yourself as an engineer and as a better well-rounded engineer. So I found myself at this company called Romeo Power, which basically did lithium-ion battery packs for forklifts, for recreational vehicles, and stationary storage systems. That's when I kind of leveraged my internships about the cost analysis and all of those commercial aspects, and I baked that into my designs so that I could come up with a design that was not only technically feasible but also all commercially viable. And subsequently, I found myself at another startup that basically did electric trucks. I spent about 2 years there, and then finally I moved to Rivian about 2 months ago. Basically, I got poached, to put it in a blunt way. But then, so throughout my journey here, what I've noticed, or my key takeaway in this last 5 years, is there's a tremendous amount of impact that you can do as an individual in the clean tech world. And climate change is real, and you need to address it. That's the need of the hour, right? You cannot deny it. You got to be living under a rock if you think climate change is not happening. But how best would you leverage your skills to contribute in this field? So this is where the MEM degree came in hand to me, because until that point I was primarily an engineer. And what I realized is, you apart from being an engineer, you need to have a holistic understanding of how business and the other components work. And that difference and that gap is what was filled by the MEM degree. So to sum it up, an engineer with an MEM degree kind of made me a holistic person to fulfill the roles and duties that I had, and helped me branch out both vertically and laterally within my field.
So I like the way you put it, Sachin. You were talking about technical and commercial viability. It's not enough that your designs work. They have to make money for your employer. They have to make money for the owners of the firm. So that was nicely done. Mark Johnson is one of the reasons we're all here. I mean, we've looked to Mark for more than 5 years, helping us with projects like this in the energy space. He's our current, and I don't know if everyone knows this, he's our current executive in residence. We haven't had an EIR for more than a couple of years. Mark Johnson, though, I think is the epitome of an EIR because he's so deeply engaged with all our students. And I want to thank you, Mark, on behalf of all the students over the years, not just this year's crop. You've done an amazing job. Thank you, sir.
Yeah.
Thank you, Mark.
Mark's been instrumental in shaping our careers. So big thumbs up to Sir Johnson.
I
Yeah.
second that.
Well, it's been fun. It's been fun. Yeah, and for the students, the non-presenters, of course, you should be impressed, because everybody that that came and gave a talk just now really has done a wonderful job. And Sachin, you said it the best. You fused the holistic view with engineering, as Dr. Werweth, underscored. That's exactly right. And that's why you're at the best and biggest and fastest growing companies, not just in clean tech, but in the United States and the world, right? Tesla's worth $1 trillion. Rivian, Sachin's company, today became $100 billion. So it's bigger than Ford, bigger than General Motors. And Vignesh, I mean, here's a guy that graduated from a little battery company, goes to the largest independent power producer in the United States, actually, I think in the world, right, Vignesh? Florida Power and Light's NextEra. And then he goes to the largest clean energy laboratory in the world, right? The NREL lab in Golden. So my path was the same. I started in Chicago with Navigant Consulting. Navigant is now Guidehouse. Went to work for IBM for energy. And you just keep matriculating through these organizations. I served at the Department of Energy under Vice President Biden and President Obama, which that is being refunded and redone again with the new act just last week. So there's a lot of money being poured into clean tech. I encourage everybody to at least try different things. And that's what the executive in residence activities do. We try to hook you MEMers up with companies that want to pay for your engineering research, but it's good experience, a good exposure. It gives you a taste test of clean tech, and I'm here to help. So as everybody, I'm very responsive and very excited to help everybody. So thank you, Dr. Werweth.
Thank you, Mark. We debated whether Mark should be moderating or whether Mark should be on the panel, and we decided ultimately that being on the panel gave us a chance to hear more of his voice and more of his perspective, as opposed to being just a moderator. So let's start with this pretty basic question, right? What do people that are currently outside the industry need to know about clean tech and how to enter clean tech, recognizing that most of you entered, with the exception of Mark, most of you entered 5 years ago, right? And things have changed. So what do they need to know now about the clean tech industry and how to enter it?
Yeah, I can go fast.
Sure.
Yeah, I think what most people do not recognize, or I'd rather say the misconception is that clean tech is purely tech or engineering oriented. That's not necessarily the case. The way I see clean tech is it's an ecosystem by itself. You could not be in the technology field of it, and you could still be able to contribute to the field. For instance, say if you're into public policy or something, you could help shape the government policies and how the industry would evolve, right? If you're in supply chain, you could be involved in procuring and sourcing the raw materials. You could be working towards creating a closed loop system instead of trying to mine minerals each time you recycle your product. You could probably be a business development professional, or someone from commerce would be helping do what Vignesh is kind of doing, is figuring out what your project life cycle cost is. So the industry is bigger than what most people realize. That you could be an engineer and you could be a non-engineer and still contribute to the field.
Excellent. Aditya?
Yeah, I mean, if I can add, it's easier to get into clean tech industry than one might think. There's less barriers today than there were 5 years ago. Basically, there was no Tesla 15 years back. There was no Rivian. There was no Nikola 15 years back, right? So the technology is continuously evolving. What one needs to have is the passion to work hard, and a mindset to change the world, And then one of the key skills that everyone that I work with, previously brings to their roles, irrespective of whatever it is. It could be a business development, it could be a core engineering job, it could be a finance, is the ability to solve problems. So that's one of the key, skill that one should hone when they are, pursuing their masters, any course, any interaction with alumni or any other technical industry expert. I think if you have all those things, it is easier to get into clean tech industry.
Got it. Okay. Any other
And,
thoughts?
Just to add on that, from clean energy perspective, you guys must have known this. Like, this is the first time in the history that USA's renewable generation have surpassed that of coal generation. So I honestly believe that clean energy is on the right track to become mainstream in coming years, and we may reach there soon. As the current administration is focused more on the existential threats because of climate crisis. So this kind of opens up a lot of opportunities, and there are and will be plenty of opportunities, as our fellow alumni said. Like, you can keenly look out for openings or job opportunities in this space, and it could be in any field. It doesn't have to be you don't have to be a mechanical engineer, or you don't have to be an electrical engineer to get into the clean tech space. You could have a business degree, and you can easily enter this industry. And with more opportunities opening up, particularly in the solar and energy storage field, this is the right time to enter the industry. And also it's easier, in my opinion, to get into this industry.
Yeah, I met with a student this morning, and we were going through Invenergy, which is a local wind and solar developer, and they've got over 200 openings. And this is just on the very cusp of the approval of the infrastructure bill. So, frankly, I think their business is going to totally explode, not just in the US, they're worldwide. And they just develop the solar and wind projects. They don't actually manufacture any technology. They're implementing technology. So in a sense, they have real estate people, they have, legal people, they have people who are project managers, program managers, wiring technicians, all sorts of folks that some do and some don't have engineering degrees, right? Any other thoughts about what it takes to enter these days?
Pick up on your point, Mark. Invenergy, Michael Polsky, the founder, is one of the wealthiest guys in Chicago, and he founded the Clean Energy Trust, which I think a lot of students at MEM know about. But those independent power producers like Invenergy, or there's a bunch of them out there. In fact, we're working, as you know, Mark, with one of them in the Illinois area for solar, but they are high growth. And Vignesh knows this from the utility side. The independent power producers are extremely high growth and building multi-megawatt, large utility scale solar, wind, battery projects that need a lot of project management office engineers. So stay tuned to that. That's a nice focus.
Right. And I just wanted to say that Florida Power and Lighting, Mr. Johnson, when I was working there, they had a couple of people who just got paid to find coal plants they can just buy and shut them down. So it's pretty interesting market trend, to be honest. Like there are plenty of opportunities for sure.
Funny.
So how do investors or potential employees determine who the winners and losers are going to be? I mean, do you have to have a crystal ball? Does it matter that let's say you join a company that turned out to be not as high growth as, say, Tesla or Rivian or some of the folks represented here? Is that okay?
I like that question a lot. I mean, people might have different opinion here, but this is something where most of us have firsthand experience with people in this panel. Or maybe to begin with, it's really hard to predict whether or who will be the winner or loser among two companies, particularly if the two companies are early stage startups. And so, but talking from an international student perspective, I always suggest if a potential employee or has a job offer from a startup versus a well-established firm, I strongly recommend working for a well-established organization. And this is particularly helpful, if you're switching to a clean energy career from a different industry. And this is not to undermine and discourage, people from working for startups, but once you guys establish yourself in the industry, it is easier to switch jobs. And with startups, you never know when they might run out of funding. And that's what happened to me in my case. Even though you might be told, they have funding to back you up for 3+ years, that may not be the case. So if you don't have any visa issues and you are, starting afresh in clean energy space, I encourage that you work for startups, because that's where you could learn a lot, as Sachin said before.
Yeah, I think to add to what you just said, how you determine if a company is going to come out on top or it's going to go bust, primarily goes back to the fundamentals, right? Like, you got to design a product that's right, and you got to be able to serve the need of the customer base, right? Regardless of what field you go in, or regardless of you going to a startup or a big company, if you do not meet these two criterias, your company is going to go bust, and that's true across the industry and across the board, right? So like you got to be able to come up with something that one serves the need and serves the need well enough that you create a demand for it. This is my third startup, and without naming places, I've seen some of the things where you spend so much time and energy that's not even addressing the need of the customer base or your consumer base, and then by the time you realize it and you try to pivot away from it, you've sunk so much cost on it that like it becomes impossible to write it away. It's kind of like a golden handcuffs. You want to come out of it because you have made commitments to your clients, you have made press releases, but also at the same time it's eating so much of your time and cost that like it's untenable. So you got to go back to the drawing board and first figure out what are you serving and whom are you serving and how will you serve them. Doing it right the first time might take an additional a couple of days or months, but like it's far more harder to fix things once you're further down the path. And I've seen it. This is my fourth company. I've seen it over and over again. Whenever you have a product that succeeded, and whenever you have a product that's not succeeded, the difference lies in the fundamental assumption of what you're trying to solve, and how well you do it.
I think something that I'd like to add is I don't think there's a crystal ball for which company will be successful, but I think one of the main things or primary things I've seen in a lot of companies in the clean tech world is the pace of innovation. So the minute a company becomes stagnant in what they're doing, I think that kind of hinders progress. The main thing with this whole clean tech, and it's an evolving industry. So if you go to a GM or if you go to a Ford, no one knows what they want. So especially in batteries and let's say even like solar energy, we as engineers are very used to looking at requirements. There are no requirements. It's basically what you think is right and what makes the world a better place. And that basically defines the pace of innovation. So to find a company that's going to be successful, I think we should look at one, pace of innovation, two, company culture that supports it, and three, basically the uncharted territories. So I think those are the three things I would say.
And certainly Tesla embodies everything you just described, from what I can tell. In fact, my video that I posted on YouTube, I don't know if you saw it, Ajinkya, but I've got a video on YouTube I think it tries to explain what Tesla's doing. I probably didn't do it justice, but I think the essence of MEM is what Ajinkya just said, right? Which is, we're focused on innovation. You can get an MBA in a lot of different places. There's 10 times as many MBAs, maybe 100 times as there are MEMs, but we are focused on innovation first and foremost, whether it's clean tech or any other type of innovation, because we know that is the fuel, the long-term fuel for sustained business growth, right? Anything less is just financial engineering. It's just some sort of shell game. And I personally don't like to play those games. I've been in industries that did that. They cut costs, they move money around, they re-engineer products by putting a new finish on it, a new color, a new texture, a new material. But if it's the same old product every day, you're not going to innovate. That's not innovation, right? And you're not going to succeed. Any other thoughts on this topic from the panel?
Yeah, I mean, Professor, if I can, I add to what Ajinkya just said. I mean, clearly, innovation, pace of innovation, and the culture that supports it. In my experience so far, worked in a few companies. One of the key things whenever I work or whenever I interview for a company that I look for is, what problem are they trying to solve? What's an innovation, and whether it's driven by engineers or not, right? So when I say engineers, you don't need to have an engineering degree. The engineers are builders, innovators. So typically, I mean, these are the positive indicators that a company is on the right track. It's really hard to say whether it will get funding or not. That's a whole different question. Hard to predict. My previous company basically ran out of funding before I switched to Nikola. So it's really hard to say, but whenever you're interviewing, just make sure that you talk to the hiring manager, you talk to as many people as possible who are working in the company, because it's just not them interviewing you, you are also interviewing them. So if you have that perspective, I think you can find a right fit for you.
And if you have that perspective, you're going to be asking more interesting questions, more in-depth questions, which will probably, if the company's secure, the company will see that as a positive, that they're hiring a thinker, they're hiring somebody who understands and is willing to dive deep, right? Any other comments?
Definitely.
Yeah, now I'd like to, piggyback on what you just said, Professor. I think, I've been on either sides. I've been on the hiring table as well. I've also been, recruited for. One of the common themes, I personally look for when I interview a candidate is I deliberately ask open-ended questions, because that leaves room for, the candidate to think and structure his response. I'm not looking for a textbook-based answer, which anybody can go through a book and find it. But like, how will you excel in terms of ambiguity, right? How will you do when you have no instructions, or how will you do when you don't know what to do? Are you going to be able to figure your path out? Are you going to speak to the right people? That's what I basically look for. So I'm extremely deliberate when I ask questions. I leave room for interpretation. So one of the key things that I have learned was, particularly from MEM is like, not to take things at face value, but ask questions, because, probing those questions will open aspects that was previously not considered, and you'll probably realize, your fundamental assumptions are either, invalid, or it might, take you off a tangent and give you, other rooms for, other opportunities to pursue. So primarily what I look for is someone who's really willing to challenge and question the fundamental assumptions that we are, working on.
The fundamental curiosity, right? The ability to ask questions that are actually interesting or have true value in the market or in the industry. In every industry, there is some sort of dichotomy or contradiction, right? That I've found. We want safety and we want performance. We want low cost, but we want reliability. There's all sorts of these contradictions that every company has to wrestle with, right? Since you took us down this path, Sachin, maybe we should continue down this path. What else do we look for? What else do you look for when you hire people into your industry? What attributes, what skills, what What kind of people?
Right. I think one of my primary criteria is like, how do I put this? How much are you willing to be uncomfortable? Primarily, I'm a mechanical engineer by degree, but most of my work involves, electrical engineering. For the last 5 years, I've been more of an electrical engineer than a mechanical engineering. So, for the last 5 years, I've been out of my comfort zone day in and day out. It's like, it's kind of a testimony, like, previously my ex-CTO wrote me a recommendation on LinkedIn, and he primarily says, Sachin was willing to learn, new streams of engineering and apply it. So, like that's something that I pride myself in doing. I'm willing to be uncomfortable most of the time and willing to learn new things. And that's something that I look for in candidates, because that really, to me, shows that you're willing to go down paths that you've previously not considered. You're willing to explore, and you're not sitting and putting your hands up and saying, I do not know how to do it. It's okay not to know it, but as long as you're able to apply first principles of engineering, first principles of questioning, you should be able to at least know to whom to ask the right questions, and from there on, you can get work going. You don't have to solve all of it, you don't have to know all of it, but knowing and have that innate curiosity to ask the right questions will lead to solutions further down.
Excellent, Sasha. And in fact, that's one of the mottos of MEM is, my job is to make my students uncomfortable. My job is to push them out of their comfort zone, because if they're comfortable, that means they're not under much stress, which means that they're not learning much. So you learn from discomfort, you learn from mistakes, you learn from error, you learn from being pushed out of your routine, right? Any other thoughts about who you or what types of people you want to hire?
Mark, I have a point that I think is important for all of us, is that all of these successful graduates that you're listening to, fantastic people, great professionals, and you knew people at MEM, you're in the same situation. You're worthy. You're needed. You're wanted by the clean tech industry and all industries. So go with confidence that you may not know all the answers, you may not know all the questions, but you're worthy to help all of these people, not just clean tech, but all industries. And I think that's really important, that you have a seat at the table.
I like what Sachin was saying about first principles. It sounds like something a Tesla person would have said, because I think that's kind of the motto of Elon Musk. But a great first principles question in energy is, how much energy does it take to deliver the energy you're delivering? So in other words, how much energy do you put in order to get X amount of energy out, right? And unfortunately, this is 2021, not 1951. The people in the 50s didn't have to ask that, because it was a pretty modest amount of in energy input, right? But today, in this day and age, in this real world, it's a very cogent question, because we're getting to the end of the age of oil, right? Any other thoughts on attributes and on who you hire?
I can comment on what kind of professionals are needed in this industry, and how you could possibly approach an employer, because I'm not in the hiring authority at NREL, but I think the most important thing, if someone is switching from a different industry to this industry, is to talk the language of what people in this industry talk. Like it is very important to learn in detail about the industry itself. It could be as simple as selecting 10 different companies in the industry that you'd like to work for, and learn more about them, like what they do, what kind of products they are into, what kind of services they offer, and try to when you try to converse with those employers, try to converse from projects that you have done at MEM, in the products and services offered by those companies' perspective. That will really help make the conversation two-way, And that's what something I did. And it is really helpful to do informational interviews with people in a very similar role that you're seeking for in those companies. And trust me, like if the informational interviews are done correct, if you have done your homework, you'll obviously get rejected by few companies, but there is a great chance of, at least landing multiple interviews and keep your options open.
So I agree. And one simple way to do that is to use some of the tools at hand, such as LinkedIn. LinkedIn is a great database to triangulate, find people from MEM that are working in that company or that industry and approach them with a simple sentence. Hi, I'm a student at Northwestern. 9 times out of 10, people will not turn you down, right? They will find a way to answer your question or find somebody who can, right? Any other thoughts? Go ahead.
Yeah, I want to add a couple of things here. So when I was at Northwestern, I used CareerCat a lot. I mean, I used to basically be in the office once a week. That's how I got into the battery business, or I guess at the supplier, because they were recruiting at Northwestern. That's how I got, I guess, the change from like the traditional industry into clean tech. So yeah, one would be CareerCat. The other one will be in terms of like experience. I would highly recommend giving examples that you know all the details for. Especially at Tesla, when we interview folks, we always try to find out if you really solve the problem or if you just know about the problem. Usually, the former is preferred, where you know the details of the problem and you actually solved it. So yeah, 2 things that I would like to add.
Yeah, that's what's very different about, I think, today's culture, today's day and age. They're not interested in spectators. Their employers are interested in the doers. Even an engineering manager needs to be a doer. My vice president of engineering had a workstation, an engineering workstation on his desk, and he had a soldering iron on his other desk. So he was messaging, hey, he's willing to roll up his sleeves and get his hands dirty. My next question, I guess, unless there's any other comments on this one. You're all in the automotive industry, and it's very obvious to me, but yet we keep talking about energy, we keep talking about clean tech. What does automotive have to do with clean tech and with clean energy? I mean, what's the connection here? Or is it just a coincidence?
Yeah, so Professor, I guess where I am right now, from the companies that I worked for in battery technology would not only support automotive. So even at my last job, so energy was an integral part of, I guess, has been an integral part of both the companies that I've been at. Once you have the chemistry figured out, the lithium-ion chemistry figured out, again, that's a very small portion of it. You can pretty much go into any renewable energy, right? So if you have, let's say, a windmill, you can attach a lithium-ion battery to it, save the power, in like a power wall or some sort of energy grid storage, and then provide that power. So I think it comes down to a lot right now, comes down to the chemistry. There is, I think I read an article the other day which said there were more than 10,000 technologies or like formulas that they're trying to tweak to see if that'll be the next lithium-ion of the industry. Again, it takes time to develop that and come into full force. But I would almost think of it as I took marketing when I was at MEM. I think like everyone is doing. And similar to how Android and Apple have an ecosystem, energy companies are trying to set up an ecosystem. So I guess when you look for jobs, when you look for the next opportunity, see what ecosystem makes sense to you. So if you want to place yourself in an ecosystem that's driven from automotive or from like chemistry, think about that as you go into the next role.
Yeah, I think that's a great point there, AJ. I think most like piggybacking to what he said and piggybacking to the first comment I made, that like, most people fail to see this as an ecosystem. Once you realize this is an ecosystem, you realize there's a host of other feeder industries to it. For instance, like to Professor Weaver's point, yes, most of the panel is automotive, but this bunch of other auxiliary functions that's needed to to keep this automotive system going, right? For instance, Tesla, and case in point Rivian 2, that it's less of a car and more of a computer, right? So with self-driving coming in, so there's this bunch of machine learning and software stuff that goes on. So you could be a software engineer, focus on the the software aspect of it. You could be a data engineer, and you could collect data about how the battery performs or how the car performs, and like you could analyze that. You could, like you said, you could be a chemical engineer focusing on battery, and you could be in logistics and supply chain and try to figure out what your optimal charging network should be, what your where you would want to house your charging systems. And you could also be on the business aspects and try to figure out how you would want to price your charging system so that you could make most money out of it. So one key aspect to remember is, like while most of the spotlight is on the automotive, primarily because Tesla has been leading the way, and a bunch of traditional automotives are all trying to get into the EV space. So it's only natural that most of the spotlight lies there. But also, you should realize there's tons and tons of feeder industries, or tons and tons of feeder functions that these big companies rely on. So if you're not a mechanical engineer, or if you're not an electrical engineer, you could still be a part of it. It's just that you need to know where you would fit in that value chain and target that area.
All right, excellent answers. I was going to turn it over to the audience at this point to ask the panelists, anyone individually or collectively, any questions you had on your mind, because I know you've come here and you've been very patient. I thank you. Let's hear what's on your mind and what are the questions you have. This is your chance, guys. We've got Tesla here, Nikola, we've got Rivian, we've got NREL, we've got some of the best energy mines and companies in the world. Raj?
Yeah, I mean, hi, Mark. I mean, I had one question to the panelists here. So especially nothing in specific to any particular panelist here, but I wanted to understand in terms of the automotive industry currently, where it is heading. So is there any kind of projects which are specifically, or is there any specific bottlenecks which they are kind of currently working on, which I think MEM students should look into and kind of start working and be ready with, so that it will be easier for them to also contribute at the university level. So if you have any kind of projects or any pain points which you guys feel the MEM students should look into, do share, so that we can kind of get prepared and see if people are interested in that space, they could start thinking in that aspect as well.
Yeah, I can speak from experience, and I can speak from my current position. Like designing a car is easy. The question comes down to scaling, right? So like Tesla went through this. Like the famous production hell for the Model 3, where you have your design. It works on paper. You have prototyped it. It functions. So thumbs up, great. But now you built one car. Now how do you build this at a large scale, say in tens and thousands of volumes? How do you make sure repeatability is there, and how do you make sure all the stuff that you need come into cohesion to get a product out, right? So if there's one thing that I think is a bottleneck in an automotive industry, it's purely scaling. If you can figure out how you can scale quickly and efficiently, that's a big win. I would even go as far as to say, whoever scales best and quickest, gets out ahead of the pack.
Okay. So in line to the same thought, Sachin, one is scalability, I understand, but there is one more thing which kind of, comes as a bottleneck, that as you scale and then you kind of produce the vehicles, there is one thing which needs attention, is the what happens to the battery after a period of 10 years, of say 5 or 10 years, once the life is over. So is there any work going on in terms of how do we handle the recyclability or kind of disposable batteries? What is the value chain around it, and how the supply logistics are being handled? So any such thoughts on that? What is Rivian? What is Tesla? What's their thought process in terms of handling those batteries? Because not everything is kind of recyclable. You also generate landfills. You also generate disposable waste. Because the policies are also not yet concrete. Not ever in US, anywhere in the world, if you see, the policies are just still evolving. So considering that as a scenario, how do we kind of handle, what's the thought process of the industry?
Yeah, that's a great question. Yeah, that's really a great question. I cannot specifically speak to what Rivian does or what others do, but like I'll break this question into multiple parts. The first part is the question lingers: what would you do at the end of life, right? So what usually happens is it's usually repurposed. So you basically call it second life. So, for instance, if you put it on a car or a truck, where the duty cycles are large and like it's often heavy, right? So, it demands higher performance. But when you repurpose it, say you put it in a residential system, or you put it at underprivileged and underdeveloped places such as Africa or any of those poorer countries where where they have no no electricity, but you could use that to create either microgrids or nanogrids. Most of the energy there is not demanding, right? You would need a steady stream of supply, but not necessarily huge surge in terms of power requirements. So most of these batteries are usually repurposed and sold as second life systems, where that's an industry and a market by itself. And the other aspect to your point of generating landfills or trying to recycle it, one of the key studies or key value points is trying to figure out how we can create a closed loop system. You hit the nail on the head when you brought out recycling, because if you look at Apple's recent marketing, they're trying to build a closed loop system, right? That means there's no new material that's being added in. Everything that's being used is being recycled. So although it's not achieved at this point, that's a great value chain, and that's a point of differentiation further down, where if we can achieve that, you're basically creating a self-sustained system where you're not mining earth for minerals or any other rare metals, but like try to live off what you already have, right? So there's that work happening. And the third point is basically policy, right? So Cleantech, although it's been around for about 10-15 years or whatever time frame, it's still evolving, right? It's not in its nascency, but it's not mature enough that it's everyone's accepted it. This is where public policy and policy making come into question. And this is where as long as you can influence the government, as long as you can influence the Congress to create incentives for people to adapt to this, people will adapt. And basically it comes down to a question of when is critical mass achieved, right? Once critical mass is achieved, people get used to it, people get warmed up to it, right? It's like I recall in Professor Gailberger's class about organizational leadership, there was something called an S curve, if you guys have not taken it already, right? So there's early adopters, and then there's at one point where people start adopting, and then you most of them adopt, and then you have a late adopters, right? So like for the curve to pick up, there's that inflection point. That's the point of critical mass, right? So you got to actively work towards making sure the critical point is reached. And once that is reached, it picks off by itself, and it's like a domino effect where the adoption rate is will be much faster. So now coming to a point of where we want to focus, there's numerous aspects that I mentioned, right? So you have to ask yourself, what aspect of this more interests you mostly, and focus on that aspect of the industry.
Valid point, Sachin.
yeah.
Valid point.
If I could add, a great question, Raj, and great response, Sachin. So life cycle assessment is a key area of research that at NREL we are doing. As Sachin mentioned, what kind of policies we would need, maybe not today because recycling is expensive and it's not to a point where it is profitable for any business to recycle. But what kind of policies that the government could bring in, like the investment tax credits that they brought for solar and energy storage technologies, can they bring or draft some of a different tax sharing revenue schemes so that these recycling business could become more profitable? And that's, I guess, is the key area at NREL we are working on. And so doing an circular, I think anything that has circular economy at this stage of the clean tech would be really helpful for the industry to kind of manage all these e-waste that comes with a lot of innovation in the battery sector in particular. So I guess life cycle assessment and circular economy would be an interesting area to focus moving forward as the industry is picking up.
Yeah, that's a really valid point, Ramasamy. So the one thing which, in my previous experience, I was working on the life cycle assessment, but on the policy front, if I wanted to touch upon, there is something called a, I would say pacing problem, which usually comes in. It's the gap between when the, policymakers makes the actual policy versus the implementation. There is always, I would say, a lag which is coming in. So is there any work going on in that area? Because of that also you see a lot of, gaps coming in and creeks coming in, and the effective, I would say implementation doesn't happen. So that is one thing which I see is also a pain point in the industry.
Yeah, so for all the adoption models at NREL, what they do is they kind of do the parametric simulations, right? So what if the policy is adopted in year 2025 instead of year 2030? So you have to consider all those kind of uncertainty when you do these kind of assessments. So that kind of helps alleviate these kind of analysis related problems for sure.
Yeah, great. I think that's the logical way to go forward. Makes sense. Yeah.
Okay, any other questions for the panelists or comments?
I had a question. Thank you guys for coming and talking to us. It's been really inspirational. In general, do you think that the carbon markets are really driving the clean tech boom right now?
Wish they were.
Yeah. Well, I hear about carbon offsetting, and then now the big thing is carbon insetting. So
yeah, I don't think they are yet.
Yeah.
We all wish they were.
Yeah.
But I can tell you that a lot of revenue is accrued by companies like Tesla on their RECs, the renewable energy credits, right?
Right.
But that whole business of renewable energy credits and monetizing them, there is, as you know, there's a trading business going on now, but it's not as big and powerful as it should be. I think that the clean energy space, frankly, has grown because clean energy is lower cost than anything, right? 3 cents, 2 cents a kilowatt hour. You can't beat it, right? You can't beat solar and wind. So it's unfortunately a cost thing today that has caused clean energy to be so popular. But to your point, we would love to monetize credits, right? More and more, whether it's carbon credits or renewable energy credits, they need to be monetized.
But to the point of technology adoption, is talking to somebody from the business of telecommunications, I saw where Europe and China led the United States by anywhere from 2 to 4 years. So the technologies that China and Europe adopted, became much more prevalent in the US 2 to 4 years later. So what are we seeing in China and Europe today? In China, we're seeing 17% or 18% of new car sales are pure electric vehicles, battery electrics, not plug-ins, not plug-in hybrids. I'm talking BEVs, okay? Like Tesla, except they've got 200 or 300 other models and car companies that are much cheaper and arguably suited for that market. The Europeans, the most popular car sold in Germany in the month of September was Tesla Model 3, above and beyond any Mercedes, Volkswagen, Audi, BMW, right? This is in Germany, where the German plant for Tesla isn't even built yet. So I think that's an indication that I think we've hit some sort of cusp, turning point, inflection point, whatever word you want to use, right? Maybe AJ wants to argue it or support it. I don't know, but I saw you smiling, AJ.
That's true, Mark. So the Giga Berlin is not even running yet, and sales are pretty good. So
pretty good. BMW and Mercedes and Volkswagen would love to have all of those sales, even split between the three of them. They would take them in a minute because they're scared of your rate of ascent. They're scared of your curve, right? And if that's what you're doing in September of 21, what's it going to look like in September of 22?
Right.
Yeah, a couple of things that I wanted to add, I guess, from before and to this point. So one was there was a survey done, I think, last month or 2 months back, and it basically said, would you prefer to buy an electric car or are you just buying a Tesla? And the overwhelming response, I think it was more than 50 or 60% was people wanted to buy Teslas and not electric cars, which is good for Teslas, but I think at some point that does raise the question that for electrification to be mainstream, the cost of the car has to be so low that everyone can afford it. So I think there might be a lot of, to your point, Professor, there might be a lot of development happening in US, especially where the target market becomes not the luxury car market or the luxury market, but essentially more economical. So cheaper electric cars like China has. China, Europe are leading US in the whole electrification field, which I hope US will catch up. It's going in the right direction. And then the other thing that I wanted to add from, I think we were talking about recycling before. So electric cars, so Model S really became mainstream, which was the first electric car in the 2014 timeframe or 2013 timeframe. So I think someone said 10 years. So 10 years to that is 2024 or 2023, which is approaching very fast. So there's a lot of lithium recycling companies that are coming up. If people are interested, I do have a few contacts in that industry because a few of my coworkers, they started their own companies. They went and are working for lithium recycling companies, battery recycling companies. But that's definitely a big market that's coming up. So keep an eye out for it.
In fact, that's one of the projects we're working on, isn't it, Mark?
Yep.
Battery recycling and lithium, and what are we going to do with all these extra batteries, right?
Yeah, exactly. And you're right, the graduates of Tesla have started up at least one company, maybe two or three recycling. So good point.
I think one more point which you were trying to say, Ajinkya, is that the adoption of electric vehicles, that there is still, I would say, a mental block of majority of the players. And what Tesla is trying to do is it's trying to put or attach an esteem that owning an electric vehicle is also very good. So I think that also will help the conventional players, I would say, or the conventional auto purchasers to kind of migrate to an EV vehicle. So it's the approach is different, but whichever way is working out to kind of speed or expedite the adoption of the electric vehicles, that's the way forward. So either you kind of give economical EV or kind of attach an esteem to it so that people are willing to shell more, and the ultimate result is that more adoption of EVs comes in, and then you ultimately help the clean tech space. I think that should be the way forward. Yeah,
you make a good looking fast car and everyone wants
absolutely it. Exactly.
I think Satu's got a question.
Yeah, I had a follow up actually on batteries, right? Is there a sustainable way to mine and and produce lithium, are we just substituting oil and gas for lithium at this point? Like, how long would our lithium supply last, really, right? And is it sustainable?
Yeah, that's a very, very good question. So lithium, I think, so that's another limited commodity, like fossil fuels. So it's another limited commodity. So the emissions of that are low, which we know. But again, I think if you're able to recycle that, that'll be a good thing for the industry. Again, you can recycle 100%. So at some point there has to be where the curve drops off, right, to what you're saying. What I was saying earlier, so there is a lot of chemistry. So there's a company called CATL. You guys can probably look it up. They came up with I think it's a sodium-powered battery. And so I think Toyota had a prototype car for it. And then CATL has a battery, made out of, with this chemistry or with this different, I guess, like factor. So it kind of ties back to the pace of innovation, right? So lithium again is a finite resource. As that goes down, there'll be other more sustainable things that come up. So there's also I'm trying to think, like a nitrogen powered, or no, I'll send a link here. I have to look it up, but there's a car that Toyota is marketing pretty like crazy right now, which runs on, like, I think, nitrogen gas or something. So, but yeah, at some point lithium will die off, and then there'll be new technologies that come up.
Well, the first priority is going
Vignesh
to.
Ramasamy hasn't spoken up because he graduated from Vision Energy, which is flow battery. Honeywell's got a flow battery on the market now with Duke Energy, and there are different approaches, different technologies, and we will graduate. You saw where even Tesla is, graduating beyond just lithium. So,
yep, I think the market is more focused on lithium right now because they have figured out how to be cheaper.
yeah.
And the other technologies, it's really hard for them to bring down the cost, particularly the long duration batteries. The long duration batteries, they don't really have a raw material problem, because the company that I worked for, the raw materials they used were like salt and water. It was pretty simple chemistry, and but they were too expensive. They were twice the cost of lithium-ion batteries, and they're only either with adoption or with government's support, they could drive the price. But unfortunately, that's not the scenario. Like, you have backing of lithium-ion at each level of the government right now, and for another technology to succeed, either lithium has to die, as Sachin said, they have to run out of the supply, or they have to find an alternative that is really cheaper than lithium to mine and introduce them into the supply chain.
Yeah,
Okay.
to add to that point is, without giving too much IP away and without giving too much away about what I'm involved with, lithium ions been mainstream because that's what everyone's been using. But other chemistries are being explored, other chemistries are being tested. It's just that it's not mainstream enough yet. If that makes sense.
Well, we're seeing lithium ion migrate to lithium iron phosphate. So we're seeing LFP batteries on the market here in the US, small scale, not necessarily in automobiles yet, but I think we're seeing small revolutions in chemistry at the battery level. I see Jay, and then I see Harsh, and then I think we're gonna have to wrap it up after that. So Jay, what's your question?
My question is in general that as of now, today we are talking about and this a continuation of what we are talking. So today we are having the energy crisis because we all wanted to move away from the fossil fuels. So as of now, we are only in the US we are able to achieve that after 10 or 15 years. So if we talk about the global requirement of EV vehicles, how the future looks, because there is a need of energy grids, there is a need of batteries. And if everybody adopts to the batteries, as we were talking about, there would be shortage of the other natural resources. So we will be back to the square one in near future.
So this is where life cycle assessment, LCA methodology comes into play, right? Understanding not just what does it take to build, but what does it take to dispose of all the products and materials that we use throughout our lives. So, you know, you go to the grocery store, which is better, the plastic bags or the paper bags, right? Intuitively, we say, well, it's got to be paper, until you realize the amount of energy and the amount of material in the plastic is so much less, the amount of energy required to transport it is so much less, that you're actually better off with the plastic bags that are being outlawed by cities across the country. So these are not trivial questions, and they're non-obvious answers. And that's where people like, you know, Professor Jennifer Dunn over in chemical engineering, she's done a lot of work with LCA. If you ever go to a green chemistry conference, LCA is one of the things they talk about. So it's not necessarily an easy answer. Harsh, did you have a question?
Yeah, thank you so much, Professor, and thank you so much, everyone, for joining the meeting. It's really insightful. I have two questions. First question is, a couple of weeks back, I met one of the person, Ivana Genmokova. She's a managing director for the strategic communications at FTI Consulting, and she's from the hydrogen part. So my question is, let's say we are right now talking about EVs and the energies on the electrical side. Tesla is one of the major person that we are talking about. What if in the coming years, like 3 years, 4 years, because hydrogen is again is on the invention part, and if case hydrogen engine is gonna be commercialized, what will be the trend for the EV and for the Tesla, how it's gonna impact? Because the industry giants like ExxonMobil and Shell, they are right now investing hugely in the R&D for the hydrogen part. So what's your take on it?
Yeah, I think, yeah, good question. So in terms of, I think, hydrogen power, I've read quite a few articles. So right now, I think where hydrogen power stands, at least, you know, from my research or what I've looked at, is it's still in the development phase of which needs a lot of investment, especially when it comes to like automotive or energy or using it like grid storage. There needs to be a lot of R&D that goes in before it becomes mainstream. I posted the link there just for, I guess, but the Toyota Mirai is another like a car that runs on fuel cell. I think it's pretty expensive for what you get, and to get the hydrogen, like to get gas, let's say, right, for it is not easy. So there's very few places that you can get gas. There's one here in San Francisco. So people from Sacramento usually drive here like 2 hours to get fuel. There's one. So there's very few. They're scattered. So as we go on and as we change these technologies, so if any gas station is replaced by an electric charger, electric vehicles will become popular. If you can get hydrogen at any gas station, then that will become more popular. So I think people buy things with convenience more than sometimes what's good or what's right.
Well,
right? So
they buy on what they can see, and the way
Right.
Tesla and Electrify America have situated their charging stations, very few people can see them from the road. They can see them from an app, but they can't see them from a road. So
right.
arguably, we haven't done ourselves any service by letting Shell and Amoco continue to build out gas stations and pipeline projects, right?
Very true.
But let's think about it. Hydrogen today comes from natural gas largely. So
Right.
it is not, it's fossil fuel driven until we can go to electrolysis or some other electrolytic mechanism, which is years into the future. And we're going to need a lot of surplus electricity. And we're back to that question. How much energy does it take to deliver the energy that we use?
Yeah,
Right.
I agree.
So just to add, one is definitely the
Yeah.
availability of the hydrogen, which Mark, you were saying. The second thing is the technology per se. Even if I kind of focus on automotive per se, if you see, the hydrogen has to be stored at more than 200 bar and then has to be efficiently used. So that becomes again a power output versus the total weight ratio which you are saying in, and that doesn't kind of fit well today based in the technology what we have, especially on the cars which are the requirements. So I think still it's a kind of a long way to see how we can commercialize the actual hydrogen IC engines or hydrogen fuel cell, especially on the cars thing. So both it has challenges in the powertrain per se and also from the generation perspective. So I think these two are the main bottlenecks in adoption and commercializing the hydrogen technology per se. So the logical thing would be definitely kind of invest in EVs, transition to EVs, and then maybe to the hydrogen fuel cell or hydrogen IC engine. So I think that's
every hydrogen car that I've seen so far is basically an electric car with a hydrogen fuel cell.
Absolutely.
And often with a battery attached to that to support, when the fuel cell is, erratic or needs additional storage. So we have maybe time for one or two more questions. We have two Yashas. Can we start with Yash shorthand and then go to
Professor, if I can?
I think we have time for maybe one more question before I have to leave. Yash Wardhand, you've had your hand up patiently.
Yeah. So this is just a follow-up from the question of alternatives for lithium-ion batteries. So I read somewhere that Tesla was actually planning for ultra-capacitor battery. So does any panel member have any opinion why they stopped using that?
I'll have to look into it. Yes, good question.
Okay.
It might be even IP related. I don't know if AJ can answer to it.
Okay.
Oh yeah, Sachin, what is the chemistry you said you guys are working on?
Hey, let's
I
not go
can tell
there.
you that there are capacitor-based systems in China that are running buses. The problem is the range is not very long. The charging times can be somewhat short. So they use them in commuter buses, rush hour. So at the end of the rush hour, they charge them up, get ready for the next rush hour. And that system seems to work for buses, but I don't know, maybe other vehicles might fit that model as well. Mark?
Oh, no, I agree.
Okay. All right, Cody and Yash, anything pressing? Cody, you want to go first? And then we'll finish with Yash.
My question is about adoption of electric vehicles in the country. And I believe currently it's hardly 2% is the adoption rate. And like Ajinkya said, it's the convenience that that makes people go buy the product. So when it comes to convenience, gasoline still makes sense because let's say fuel is running out, you go to a gas station, pump it, and bam, you can go out. But if it is EV, the best case scenario is supercharger, which takes 15 minutes. And the lean period is very high right now for recharging the batteries. So anything that the tech, all big companies doing right now to make it more efficient and maybe make it like a gasoline, just go to a station, bam, charge it in like 10, 15 seconds and go out again. Anything like that?
Well, I'll mention that we've got 1 million pickup trucks alone on order, back order, with Tesla, just Tesla, right? This country is a pickup truck oriented country, right? It's one of the most popular vehicles on the road. When you see 1 million in back order, that's a non-trivial amount. That means that something's changed here. So I think the adoption from a psychological perspective is there. The build out of the network is being funded by this bill that was just passed, but also by companies like Electrify America and Tesla and others that continually build out. You can go from coast to coast today without any problem.
Yeah.
In almost any electric vehicle.
Yes, yes, that's for sure, because the network is very wide and very well placed. But I was wondering, when we recharge the batteries, right? There's a time where we sit at one place and we go nowhere. That's one point I was looking for. So, but yeah, makes sense.
You mean how long does it take? I mean, they've gone from 20 minutes down to 10. It's the chemistry, but it's also the charging rate. It's the software. It's everything built into both the EVSE and the vehicle itself.
Yeah, I can answer to that because that's one of the fundamental problems that I deal with. That's part of my responsibility at work too. So it comes down to energy transfer from point A to point B, right? In this case, you're either using a cable or you're using a bus bar to transfer that energy, right? The source can provide, but the question is the conduit, right? So now you had to deal with heat generation and how big of a size would you go on a cable or a bus bar, right? So, for instance, if it's a stationary storage application, you're not really worried about dynamic movement and vibration. On an automotive, that's not the case. Your primary concern is vibration, and vibration over a period of time will fatigue your part and it will fail. So so you really want to keep your mass down. So inherently, when you try to keep your mass down, that means you cannot upsize your cables or your bus bar. And the size of the cable and the bus bar really determines the ampacity that it can carry, or how much current or energy it can carry. So unless you come up with a configuration of your bus bar or your cables that can carry higher density and energy through with the shortest with the shorter mass, that's going to be difficult. So fundamentally, you're limited by physics and not by the technology, or not by not any of the aspects. It's the fundamental limitations of physics.
Okay, Yash, you get the last word.
Thank you, Mark. So I have a question which is in the different vein from all the questions that have been asked. Considering all of you came from different backgrounds and have migrated to Cleantech now, from a tech stack perspective, and from because I'm asking this because I'm coming from an IT background and I'm working with Mark Johnson on a project as well. Considering that some of you have been on the recruiting table as well, what skills or what type of knowledge are you looking in, like potential employees about what they should know, and what kind of work are you looking at, like in terms of recruitment, and what are skills that we as students can develop?
Right. So I can answer that. From a tech perspective, you might be working in a clean energy field, but like you're still primarily using your discipline to to contribute to the field, right? For instance, you're probably a programmer, I would presume. So you'd be programming either the software for the vehicle. You could be programming the the network architectures, or you could be programming a platform that deals with vehicle fleets or charging infrastructures, or even planning the routes, right? One of the key fundamental aspects that we need to remember here is most of these EVs, they're smart vehicles. They're not dumb. They're smarter than your traditional car that just has an ECU, right? Most of the cars that has an ECU, the system in the car that is localized, right? Meaning they're not connected anywhere else. But that's not the case with any of the EVs. Tesla, for instance, can do an over-the-air update to all of your vehicles. AJ can speak to this. You probably have a bunch of cars lined up in a parking lot, and you just drive through with another vehicle, and each of those cars just get updated with the latest software all by itself, right? So a lot of that fundamentally requires software engineering or some sort of computer engineering, right? So I would suggest you focus on those aspects where you're building the infrastructure and the network, or even the operating systems for those secondary functions to be functional and up to speed.
Got it. Yeah, thank you.
Okay, I do want to thank everybody. I do recognize it's very, very close to 8 o'clock. We promised to be done by 8. I want to thank all the panelists. I want to thank all the attendees, especially Mark Johnson for his work over the years. Thank you all for being here tonight. Nice job.
Thank you.
Thank you. I'm going to save this recording and put this on our YouTube channel, so you'll be able to see it probably later this weekend. If there's anything that you need me to edit out from a panelist perspective, let me know. Otherwise, it'll be out there by Sunday. All right. Again, thank you all. I appreciate it. Cody, I wish we had more time for your question, but send it to me by email. Maybe I can get it answered for you. Okay.
Sorry, that was the previous one. I just lowered my hand.
Yeah.
Thank you.
Okay. Sounds good. All right. Take care, everyone. Thank you all. Have a good night.
Dr. Werwath.
Take care.
Thank you, Professor. Thank you, everyone.
Thanks,
Thanks, everyone.
guys.
Have a great day.
Bye-bye.
Good day. Bye-bye.